Okay guys, in this chapter we're going to be looking at rectangles, rhombi, and squares. And so I just want to start out with the rectangles. Okay, many of us know, or maybe we have some idea about what a rectangle is. It's something we've known for a very long time probably. But the mathematical definition of a rectangle is a quadrilateral with four right angles. So a quadrilateral with four right angles. Now, so rectangle is a classification of angles. So just like in triangles, we have classification by angles, we have classification by sides. The same thing is true in quadrilaterals. So a rectangle is a quadrilateral with four right angles. So then there's a few different properties here. Okay, and so first of all, if we have a rectangle, okay, so let me draw this. All right. So if we have a rectangle, we have four right angles. Okay, so A, B, C, D. So A, B, C, D is a rectangle. Okay, then it follows a couple of things. Number one, the diagonals AC and BD are congruent. So AC is congruent to BD. Okay, so the diagonals are congruent. And I just want to talk about why that is. Well, again, if this is a rectangle and you divide this up, then you're going to have congruent. You'll have congruent triangles because triangle ACD is going to be congruent to triangle. So ACD is congruent to triangle CAB. Okay, so these triangles are congruent by SAS or by many of the congruence theorems. So this is true. Okay, and furthermore, if you have the converse, right? So this is a theorem. If ABCD is a rectangle, then AC is congruent to BD, and if ABCD is a quadrilateral and AC is congruent to BD, then, so if this is your situation, then ABCD is a rectangle. ABCD is a rectangle. Okay, so again, we have rectangles, a quadrilateral with four right angles. They have a few different properties. Rectangles' diagonals are congruent. And if you have a quadrilateral, the converse, if you have a quadrilateral with congruent diagonals, then the quadrilateral is a rectangle. I also want to note that all rectangles, so all rectangles are parallelograms. Okay, rectangles are parallelograms. And why is that? Again, this gets back to this congruent triangles. Okay, so if the triangles are congruent, then you have a situation where the alternate interior angles of the triangles are congruent, and so that makes BC and AD parallel, and that makes AB and DC parallel. So let me just write that down for a minute. All rectangles are parallelograms. And again, the reason that is because of the alternate, the reason that is because we have congruent triangles here. And so if we have congruent triangles, then angle CAD is congruent to BCA. Okay, so if these two angles are congruent, then if you have alternate interior angles that are congruent, then that means that these lines are parallel. BC is parallel to AD. So these are some different properties of rectangles. Over here is how they're applied in different problems. So we have a rectangle here. Again, the definition of a rectangle. We have a quadrilateral, and there are 4 right angles here. So this is a rectangle. Now, we're given that AC equals 10. We want to find BD, well, we want to find X, and we want to find OA. So we know that BD must be congruent to AC because the diagonals of a rectangle are congruent. So 10, we write it up here, 10 is going to equal X plus 3. So X equals 7. All right. So X is going to equal 7. Now, what does Y equal? Okay, so what does Y equal? Again, we're looking at OA. Okay. So in this, we know that, again, Y is going to equal 5. Let me just give you the answer and then explain. So the reason is because in this setup here, we know that AB is congruent to DC. All right, we know that's true. We also know that since all rectangles are parallelograms, we know that angle A is congruent to angle BAC is congruent to angle ACD. So these two angles are congruent. We also know similarly, because of alternate interior angles, that these are congruent. Okay, so by ASA, then triangle. Okay, so let me write this down. Triangle ABO is congruent to triangle ABO CDO. So if those are congruent, then we know that AO and OC are congruent. So if these are congruent, that means, well, we don't know the value, but maybe the value equals, let's just say X and X. But we know that AC is 10. So if this is, if AC equals 10, which equals 2X, then maybe I should have put Y here. Let me put Y here as a little better example. Okay, so that's Y. So this equals 2Y. Okay, then Y is going to equal 5. All right, so that's how that works. Moving on to this example. And actually, it's just not just AO that's 5. DO is 5, CO is 5, BO is 5. So all of these segments are 5. All right. So moving on, AC is 8. So this diagonal is 8. BD is 8. Angle A equals what? So we want to know what is the measure of angle A. And by A, I really mean the measure of angle BAD. Okay, the measure of angle BAD. Okay, so let me be more specific there. So this whole angle, what is that going to equal? Well, we know that if we have a quadrilateral and if the diagonals are congruent, then what that means is that we know that these angles are congruent. So let me see here. These angles are congruent because they're vertical angles. We know that these angles are also congruent because of vertical angles. Okay, and we know that these lines are congruent because it's given. So because of that, we know that this angle, following from this theorem, must be 90. That must be 90 degrees. So we know that this is 90, and actually we know that all of these angles will be 90 because by this sort of logic, this ABCD will be a rectangle. So these are just some of the properties in the definition of a rectangle. Next, we're going to look at rhombi and then go from there. Thanks for watching.